And I think
today, aren't I? Okay, hey, I'm Glenn Dean from NBC Universal and Comcast. And this is a talk about a project called Gigi. There's been some showing of earlier versions of this at the IETF. We did a big session in Berlin here at Dispatch, and we also showed it in bits and bytes. What I'm going to show you today is version 2, and this is based upon a talk that I gave last week in Paris at École Polytechnique and at the MPLS forum symposium. Next slide, please. So it's a weird title, glass to glass. If you're a networking guy, content guy, glass to glass, sometimes it lists the first question, what are you talking about? And in this case, it refers to the glass of the camera all the way through the entire ecosystem until the glass of the screen. So it's how do you manage content from capture to display and all the steps in between. For this purpose today, though, I'm only going to talk about distribution. It's a very big topic. We'd be here for weeks if I was going to cover the whole ecosystem. But there's two primary goals that we've got in Gigi. One is to enable video streaming to scale better on the internet. The internet pipes are getting very full from video. And while we continue to add more capacity in the form of bigger pipes, and we continue to get better codecs, maybe we can do better. Maybe we can do stuff that can give us an extra 10, 15, 20% capacity. And if we can do that, then people get a higher quality video. And it also allows us to expand video into markets that are not tier 1 markets today. So like places like Central America, Southeast Asia, more rural areas that don't have big fiber connections into the homes or into mobile devices. How do we get better quality video to them? And the secondary goal is to be backwards compatible with the deployed infrastructure. There are countless MPEG dash players out there today, countless HLS players out there today, and countless CDN infrastructures. We can't just throw that all away and replace with new stuff if we want people to be able to access and benefit from these new technologies. And there is a connection to ICN, which is why I'm here. Next slide, please. And just hit the, oh, you're showing the non-animated versions? Okay, we'll do the non-animated version. Oh, that'd be great if you could. They're pretty. The non-animated version is sort of a deck I make available to upload to, file shares and stuff like that after the fact, so people can watch it without having to have an animation player. Because the animation players invariably break after a year or two. Every time we get a new version of PowerPoint, it seems. All right, so go into, I think, there we go, that's perfect slide. This slide right here, you just hit tap to start the animation. So we have undergone an evolution of how do we do video. It started out in the old days where we had film. And the first movement of video in the form of film onto computer accessible media put into a single file. And that was also the first evolution of how we distributed content, right? We started to rely upon file distribution tools, even as far back as FTP, to move that file to the computers so people could watch it. And then we added streaming so we could store the file on the server and pull stuff over incrementally. Since then, a lot of people, and you guys get into video, I understand that, so you'll probably already know this. Since then, video's evolved to where they've broken up that single file into packaged segments. So each segment here, in MPEG dash, for instance, is a 2 to 15 second portion of that file. And they're packaged in such a way that I have alignment to the iframes, and so I can play a complete clip independently of the other clips. I don't have to have the previous clip to have all the quantization tables and all the other stuff that MPEG encoders and other encoders require. So they're all self-contained little movies. And then we're moving next into the next world where there's a thing called CMAF that's coming out, which is bringing a commonality of both MPEG dash and HLS access. I can have one packaging in here, and then CMAF provides me access via either HLS, which is all the iOS devices, or Dash, which is pretty much everything else to access screen video. And this is actually a big step forward. It's still being developed, but this is the evolution that we've seen. And it's the problem space we have to work in, these last two, these segments and the package CMAP. Next slide, please. So let's break this up a little bit. And this is where the ICM part starts coming in. It's about naming. So if we look at historically, we've got this concept of a work up here, this film, and we give it a title. Let's call it Minions. We're going to come back to that because that becomes a root anchor that we use throughout the ecosystem to reference the work. Okay? And a work is a particular version of film, like an edit, or it's a master original film. So to break this down, Star Wars, the original one, before they added all the special effects, would be one work. The second Star Wars, where they went in and started adding digitized images and stuff like that and reworked it, that's a completely different work. It's an edit version. It's an evolution from that original work. And they both get distinct identifiers ultimately. Anyways, files, it was just a URL plus a byte offset. In MPEG Dash, with these segments, this is an example of a URL. You have a traditional, right? You have the protocol, the host, and then we have the path to the individual segment here. And then under package segments, you can either use a Dash manifest or an HLS MU8 playlist to access the transport streams. And it does the translation for you to make it sure it looks like the right thing you want. Next slide. So where are we going with all this? Well, that evolution I just broke down there, a different way of looking at it is that the people doing the work at the segment level have taken what is video and they've started applying computer science to it. They've taken it from a single file, a single object, where it has no structure really. I'm doing byte offset access, and they've turned it into a new, more complex structure that decomposes that single file into all these individual segments. You with me so far? So now I've got a lot of little videos that I'm managing, but it's a big step because up at that data level, they started treating their stuff as individual chunks of structured data, and they've packaged together at the application decoder layer as something meaningful. So then we got to thinking. Early videos, transport stuff looks a lot like moving files, that single file, and all we did was start moving a lot of those little single files. We said, well, could we do something smarter? Is there a different way of approaching this problem? And in particular, does V6 offer anything new we can do? Well, if we start decomposing these three packagings inside of a typical Dash thing, on the left or the right-hand side, your left, my right, each of these represents a group of segments that are different bit rates. So it's the exact same movie, exact same pictures, but each of the frames has a different level of compression applied to it. So an 8 megabit image is the highest quality here, has the lowest level of compression, all the way down to a 1 megabit image, less data, higher compression. And we do this, of course, to get this through pipes. When you have constrained network environments, you can get a 1 megabit stream much more reliably through than you can get an 8 megabit stream. And so this is how we do adaptive bit rates. You have a common packaging, 3 or more encodings, say, and then the player gets to decide which of the encodings it's going to play back based upon available bandwidth. You with me so far? Excellent. This is a good crowd. So what we said was, wait a minute, this is a data structure that's up there in the application packaging of the video. Could we start accessing it directly with IPv6 addresses? In other words, can we do direct access into that data block using V6? And I'll get to why that's useful in a little bit, but let's just make that leap. Okay, hit enter or space bar, please. So this actually turns out to be really easy to do in a backwards compatible way. Because over here on the far side here, we have essentially what appears inside of a manifest for Dash. Okay, those are all the references, the file and the bit rates and individual segment ID, that's represented by the X's, and the server. Well, it turns out if we replace all of that with these addresses, the new manifest looks like that. And it turns out if you do that, An MPEG-player out of the box today can just play that. Doesn't require any new hacks or changes. It just works, which is kind of good. So we've got backwards compatibility so far. Now on the player side. So we've got one thing going for us. Next slide, please. So let's look at what these segments are looking like now. And how do we package these things up? So here's our segments we had before. Now I've organized the IPv6 addresses. They're all under a common prefix. And then the individual addresses are assigned to these different bit rates. And I package them up in a thing that looks a lot like a 2D array, by the way. This is a data structure. This is a network level data structure. We refer to it as the media encoding network. And the reason we refer to it as a network is that if you look at these things on top, they are organized in a graph. That's what the on top data structure is in the most generic way. We have also created a graph down here of references to that data. So packaging together forms a network. So with me so far? All these things are very simple. They're not revolutionary, but when you put them together, they're pretty powerful. And we have here all the packaged media address references. So this is how we're starting to look at this thing. And by the way, this media encoding network that I'm showing you here is a really simple example. It's not the only one you can do under what we've envisioned. You can create other media encoding network structures to work with algorithms that make building caches and CDNs more efficient. Yes, quick question? Yes, and more than that, in fact, you have a static IP address for every different encoding of that same video. Ah, you're correct. But the address we're talking about here is not the address to the server the data stored on. It is an address to the content anywhere in the network that it exists. And where we're going to go with this is, it's an IPv6 address that points now to content, not a host. And what that now lets us start doing is, I told you these things build up small, but they get very powerful. We can now start using the routing layer of the network to direct the player to the most optimal cache for the content he wants to play. I told you we'd get there. Next slide, please. And hit space. So we thought about this a little bit, and I'm old. You can tell from the gray hairs and the parts that black hair. I went back to a few things from the old days, right? So here's Nicholas Wirth's famous book about algorithms plus data structures equal programs. When we put that together with another thought, hit the space bar, please. The network is the computer. And so again, this is the ICN way of looking at things as well, right? It's you start packaging up these references to the content, which is up in the content space. We now extended the network up to understand that packaged content, and we've built it in a structured way so that we can now start applying that to how we do caches, how we do CDNs, and how we do routing. Starting to come together now. Next slide, please. So to make all this work, there are three essential pieces. The first one is the media identifier. This is the reference to the name of the work. So if I want to talk about minions, which is what that media identifier is right there, this is a digital object ID. You'll recognize it. You guys are all people that work in this space. And there's a system for professional content called ITER. It's actually not just for professional content. Groups like Google are members of ITER. And the content management system within Google, I know, has a field that can store ITER's reference into YouTube videos. So it's used in other places, but I'm a professional content guy, and professional content uses this stuff. And it's a great way because we can now actually refer to things. But by the way we designed this thing is not just ITERs that stick in there. It's actually anything you want to stick in there. You can stick in an object DOI from ITER. You can stick in a content ID from YouTube, you can stick in something you made up for your own content management system. It doesn't care. It's got a box that says, what do you got? Stick it in here. And then we have this other part over here. This is where we have the addresses, right? Each encoding of that work has an address. And we aggregate that network together under a prefix. This is how we start getting it to be scalable. Instead of having to store all of the addresses, we store the prefix. We get an aggregation for the work. And by the way for Dash it works out in terms of addresses, you don't really need this big a space. In reality, what you need is a very small space, because in 2 to the 11th bits, you can store a 2-hour movie. Sorry, you can store a 1-hour movie. 2 to the 12th bits, you can store a 2-hour movie, and plus more reliably. Because it works out to roughly 1,800 chunks per hour of video you need. And then to connect it all together, we've created this idea of this MARS service, right? A media address resolution server. And that offers bidirectional mapping between that identifier and this address, and this address and that identifier. So I can ask questions over from this far side. If I have the identifier, I can say, give me all the different encodes of that particular movie. That allows us to do things like dynamic replacement, because one of the unique things about video, you know, if I'm talking about a lot of pieces of data, like a database or an email or an image, when I say a particular email, I mean that particular email. If I say a particular piece of data, I mean that particular piece of data. When I'm talking a movie, what I'm really talking about is the work. I want the image, right? If it's a picture of a minion in a scene and a collection of scenes together to form a movie, I don't care if that piece of work is encoded with MPEG 2, MPEG 4, something else, something I invented, DP9, doesn't matter. I want to watch from a user viewing perspective. I want to play back what my device can get most efficiently. And so now we can start doing things like dynamic selection of content, not just based upon how near it is, but also the quality and the appropriateness. And I can substitute different encodings, or if I ask for an MPEG encoding, I can say, well, by the way, I've already got a better quality encoding. That's an MPEG 4. You asked for MPEG 2. How about I give you that one? Can you play it? If you look at most players, they can play dozens of different formats. So I can start doing very smart content sourcing. Next slide, please. And so we blow up this whole picture. And this, from a, you guys do data and content networks. This is very similar to, I'm imagining, your ways of thinking. Because, by the way, we stole a lot of these ideas from you, unabashedly. Over here, we have the concept of things that are assets. These are things we refer to by name. They are distinct. Over here, we have the concept of services and resources, containers, distributions, and coding. These are things that often have a many-to-one relationship back to those assets. And then in the middle, to bind them together, we have MARS, the Media Address Resolution Service, the network, and APIs for applications. Next slide, please. I'm almost done. So this, if you broke out the media ecosystem today that is used to deliver video from a source to a player, this is roughly the big set of discrete levels you have. Okay, up at the very top, we have applications. And then going down, we get all the way down to the GORPy stuff at layer 3. Now, how does Gigi fit into this? Hit the space, please. So Gigi does the following. It adds a couple basic pieces. The biggest thing you see in the middle here is this packaged media addressing. This is the media encoding networks. This is the way we bind or connect the stuff down here to the stuff up here in the packaged media. Make sense? This is the MARS server down here. This is the direct addresses. These are the issuance of IPv6 addresses to the different encodings. The GGURI here is the thing that carries that IDER or that content identifier. So for instance, you would use that in a search term, or you could stick into a playlist or an electronic program guide that would go on a UI. That UI would contain the URI for the work, and then it would talk to the MARS server to get the set of addresses that it has access to of where to source that content. And again, it's the address of the content, not the address of the servers holding the content. We also extend the routing layer to understand how to work with that. A couple ways of doing that, and we're going to show that to you on Thursday. And you can also work looking at using segment routing to use some very advanced stuff there. Because one of the things that this now lets us do, and I'm really excited about this, because I'm a nerd, is once I've got this in place, I've now opened up all the new tools inside of IPv6 to allow me to do smart networking to deliver content. So I'm no longer now just using those tools to talk to IPv6 servers. I can now start talking to IPv6 content. And this is the real power here. Next slide, please. So this is the part where I would show you a really cool movie. It's a big movie, so I don't have it with me today. But I'm going to do better than that. On Thursday at Bits and Bytes, at the NBCU table, I have this running live, because we've built it. It's not just theory, we went out and built the darn thing. And so what we have live, and you'll see it, is we've built CDNs, 2 different CDNs placed on the real internet. We've got a small Raspberry Pi configured as a home cache device. And we've got a Mars server, again, on the real internet. This is connecting through a real home router. Okay, this is just an out-of-the-box Comcast router. And we've assigned addresses to minions. We got encodings of Jurassic World, and we've placed them in different caches. And we, in the demo, show you this all running. The players, these are 3 players we've created over here. They've each got a little mini EPG running inside them. And you can select what movie you want to watch, and it'll call it up from the nearest cache. And we've got it working with, in the home environment, using both ISIS and, oh, I'm blanking. What's the other home net routing protocol? Babel, yes. So we are actually running with both. It was pretty easy. So if you, and by the way, this is done a partnership with Drexel University to grant some context. Next slide, please. So getting back to this is how it all comes together. This is the media ecosystem. Next, please. And here's the last bit. So we have a bar bot to talk about streaming video over the internet tomorrow night over at the Fairmont Bar, if you're interested, from 6:30 to 7:30. We are also going to be at the Bits and Bytes showing Glass to Glass live. So come play with it. Tell us where we got wrong. Tell us where we can get it better. And we've also got 4 drafts out there of these ideas, so people can sort of poke at them and understand what we're trying to accomplish. And that's it.
So,
any questions?
Yeah, I have a question. One of the trends that we've seen very, very strongly in internet video is maintaining privacy of who's watching what. And hence, even though the videos themselves may be encrypted, people like YouTube and Hulu and everybody else who's offering streaming video runs the sessions over HTTPS so that you don't actually know, you have no way of knowing what, but be an eavesdropper, what anybody's watching.
Yeah, you know.
And this seems like when you map something to IPv6 addresses, you're like broadcasting to the entire world, not just what you're watching, but every single frame you're watching.
You're right. That's an excellent observation. You're completely right. So gosh, that would be a problem if we didn't have a way to get around it. So here's the way we think to get around that. When you connect to your video source, your initial routing is accomplished through that well-defined address. However, you can then renegotiate a dynamic address assignment. Just like if you imagine in IPv6, you can have 2 hosts on the network that suddenly negotiate a session level connection that's only between the 2 of them.
But then the number of IPv6 addresses used is not the number of chunks, but the number of chunks times the number of users.
But there's 2 classes. So one class is a class of addresses which are assigned persistently, and these other ones are addresses that are assigned on the fly just for that session. And like I say, it's about 1,800 chunks an hour. So essentially what we're saying is, for an hour of video, we're going to use 1,800 one-time addresses.
So that's a million people watching times 1,800 is
insignificant to the power of the force.
Well, remember, these aren't just the low order bits of the IPv6 address. These have to fit in the prefix part of the IPv6
No, the prefix
address.
can actually stay. The prefix can be
no, because
if
the prefix is the same, you know what somebody's watching.
No, the prefix can change too, but the prefix can remain the same per cache. So an individual cache can actually use the same prefix for these individual sessions, because you're still able to tell what cache he's talking about if you're looking at the traces and then at the network level. So We call this dynamic renumbering for the session, and our belief is that it does mitigate the privacy concerns, because they're real privacy concerns, and I have them too, because as a content company, we don't want to know what you're watching. In particular, we don't want anybody else to know what you're watching, because that way you're comfortable watching whatever we have to sell. And, you know, as I say, my studio makes the Kardashians, and we want you to watch it because we get ad revenue from it, but we realize you may not want your neighbors to know you're watching the Kardashians at 3 o'clock in the morning. So privacy is very important.
So let me just get, I mean, I know how these routing protocols work. Can you actually churn the routing protocol every time the session starts?
I'm told by I'm not a routing expert, but I'm told by the routing people this isn't a problem.
Oh, I know the segment routing people will tell you it's not a problem, because they will tell you that nothing is a problem.
That's a good observation, actually. But anyways, this is how it does work.
Great.
So,
thank you.
Hi. Okay. I am the Kutscher. Thanks for bringing this work to the group here. Okay, so Dave asked the first of my questions. So is like security a topic at all in your work? For example, do you try to prevent cache poisoning and these kind of things?
So at this point, it's an R&D project.
Yeah.
We haven't tried to prevent cache poisoning because so far the model that the caches are populated with is a forced top-down model, so they're controlled what gets put in them. If you ever get to the point where you could have caches that started loading up themselves, then I think you'd have a problem with cache poisoning, and you'd have to look at the potential attack vectors there.
So right now it's all pre-positioned.
Yes.
Okay.
At the cache level. But that's just because we haven't got to the next phase where we would have dynamic caches. We've talked about it, we've thought about it, because it's something that's really cool. You know, one of the use cases we have is the ability for two devices that are completely off the internet to actually form an ad hoc relationship and allow you to stream from one device to other. So for instance, you're on the beach, you've got a camera that's taking video there on the beach, but you're on a beautiful remote beach. It would be really good for people locally to be able to form an ad hoc network and allow you to stream from one device to another device on the beach. Or maybe I'm on an airplane and I've got a movie on my iPad that I want to share with you, and we don't have reliable full-blown internet access, but we can stream over the in-house Wi-Fi. So these are use cases that we'd like to accomplish.
Is this a proposal for the general internet, or is it like for something that is driven exclusively by NBC for private domains kind of thing?
So the intention is, it's an R&D project, but it's an R&D project we're hoping will have benefits for our global content distribution, which means it's for everybody. And that's why we are talking to groups, and we've written IDs here at the IETF, and why we're having a BOF, because we want these things to be looked at and discussed by a lot of smart people like the IETF and help us shape it. So I get up here and say, well, here's how it does work, because we built it to do it that way, okay? That doesn't mean we're done. That doesn't mean those are the only ways of accomplishing it, but it's a starting point for people to have conversations around how do we then do the next things. Because the intent is, hopefully, big picture, have one solution that we all buy into, so that we don't have, in 10 years, 4 solutions that do something very similar, but don't do it the same way. Because that it would kill us in video. So one of the costs that we have as a production studio is producing content for all these different formats and standing it up on distribution platforms to be accessed by all these different types of players. It's very expensive. Amazon makes a phenomenal amount of money out of Hollywood for doing transcodes because of all the different formats we have to support today. It's not uncommon that one movie can get re-encoded 80 different times and packaged 80 different ways. And so one of the big movements within professional media, and why we have things like CMAP coming out of the MPEG groups, is can we get down to common formats that can be used multiple places, so we take up less storage space on the CDNs, so we can put more diverse content there, and we can also save a lot of money on doing all these crazy transcodes that we do today.
But again, one of the things with name-based routing is things like, because they're non-topological and the scalability aspects of it, because you're talking about millions of titles, and now your fibs have to scale for those kind of numbers. And the other thing is that the churn that it introduces, because you're moving content here and there.
We've done the math,
So
and we do not exhaust IPv6. In fact, we don't make a big dent. The reality is, if you look at a service like YouTube, the current quote that they give out is about 400 hours are uploaded per minute to YouTube. And I've done the math, how to build a library out of that and address these V6 addresses, and will we run out of space?
You won't.
And it gets to a big number, but guess what?
No, you won't.
It's not a giant number
You
compared to a V6 address.
The address space size isn't the problem.
Now, to make it scale, you do have to be careful with your aggregation. This gets back to how you apply your prefixes for your libraries, right? Because you don't want to have hundreds and millions of addresses floating around out there. You can aggregate these things. So you could aggregate at a YouTube level for a lot of stuff. You could aggregate at a certain prefix level for all of NBC content, the entire library, which is about 6,000 films and about 60,000 short forms, right? So all combined, you got about 66,000 titles you want to short or manage in a common library prefix. It's doable. I've done the math. I don't have the math here to show you today, but
but
we have done the math.
yeah, the problem again becomes because when you're working with prefixes and you're working with aggregated names, you don't know exactly where the content is unless you de-aggregate and give those. I mean, so
Or
that
until you start changing
explodes your
potentially
fib,
how the
right?
caches look at things, right? So again, this is R&D. So you're right, you can get into some problems with aggregation. One of the ways to start looking at a cache is, instead of today, which we use essentially a file server that has a bunch of named files on it, start thinking of your cache as the same function as a router on the network, where I advertise the address space for the content libraries that I'm going to offer. And then when I get a hit, maybe I populate myself. And if I get a miss, I still resolve that by accessing upstream, and then I resolve it locally. So I now can start positioning near the edge these gateways to these libraries, which helps with a lot with the scalability, because I'm doing my delivery, my resolution, most of it at the edge, not at the core. And by the way, part of this also was to deliver some balance back to the way we do video, because if you look at video today, we're building an ever smarter core. The CDNs are getting incredibly smart. We've got great companies like Sodexis and Conviva that do telemetry that make the CDNs smarter and smarter and smarter. But the problem with that is that it kind of violates the core design of the internet, right? Dumb core, smart edge. It's building a really smart core today to make up for a very dumb edge. Part of the idea here is to start delivering control back to the player side on the edge and work with the network that's doing the routing at that edge to make the cache selection choices.
And the other thing is, you said you're mapping this 2-second to 50-second videos addressable by IP packet, right? I mean, they're really megabyte size.
Well, that's how it's done today. That's how MPEG Dash works today. Everything you watch on
No, but I'm
Netflix
saying that's
does that.
more a transport level problem rather than IP level.
They're not changing the transport.
Yeah,
This works with the existing transport.
no, transport in the sense like, I mean,
They're not changing the transport.
yeah, no, but are you
They're
expecting?
just changing the addressing.
Yeah, that's right. But are you expecting those 2-second or 50-second word chunks to be encoded in one IP packet?
No.
we're
They're
not
not
making any
changing the
assumptions.
transport.
We make no assumptions on transport. So it'll work today with HTTP, which is how they do Dash already. It'll work with the transports that are currently being used. And by the way, as long as they don't do anything really radical, I expect it will work with whatever transport you bring along that still accesses the content in the same basic patterns.
Dave, can you go back to the slide with the protocol stack? Okay. If I look at this slide, I think there's something missing.
Could be.
There's a lot of stuff on top of the yellow boxes, but I think in transport, there is something missing in transport.
Well, such as?
TCP?
Well, I didn't call that out just because it was simpler to identify HTTP as the core transport that this stuff flows over today.
TCP is inside HTTP box?
It is, yes.
Okay.
I mean, technically, look, I only had so much real estate, right? So it doesn't have every last little tiny detail, but this covers the primary way we do transport. And I know there's people who are working on multicast, and there are people who are working on
No, but let me ask you my
unity
question.
transports.
So here's the tricky thing, right? Which is if you address with an IPv6 address that is non-topological, that is content oriented, you're effectively using any cast TCP connection establishment, right? Which may work if you're really, really, really careful so that all subsequent packets actually wind up at the same instance of that logical address, right? Now, in order to make that happen, you need incredibly stable routing, which I believe you might be able to make happen, say, inside a professionally managed service provider network like Comcast, Comcast Network, something like that. It seems really scary to try and do this where you don't have really tight routing stability.
It's not doesn't need to be that stable because there's no state that needs to be maintained on the cache that's serving out the content.
No. TCP has to deliver all the packets of its connection to the same physical host, or it will break.
I understand. So one of the areas that is interesting to explore is once you have this ability, do we need to make changes in the way that the conversations are had over HTTP? Not change HTTP, not change the actual transport, but one of the areas you now have the ability to start doing smarter things around is can you, like, what I want to use, can I bundle the requests for those different packets through that single pipe without a reestablishment?
My question was related to TCP in the sense that you showed in your example that you put an IPv6 address in HTTP. So that means technically, if it is working, that you're opening a TCP socket in the client. There is a
Yes. Yes. Yeah. And the sad thing is, a lot. Well, the sad thing here is a lot of the video that's actually delivered today at scale does exactly that.
No. Not on Akamai, it doesn't. I can tell you for sure that on Akamai, it doesn't do that.
Well,
you get locked to a server until that server fails.
I didn't say every video. I said a lot of video. Because a lot of places.
No, none of the Googles, none of the YouTube stuff.
A lot of places are when they're regenerating the manifest, which they do but every 5 seconds, right?
Oh, that's live content. That's a different kettle of fish. Because you have to regenerate live manifests because there's new video every 5 seconds.
But they're also regenerating the status video because they're responding to what the information they're getting from like the telemetry feeds at Nexus and the other player telemetry. They're trying to reroute you to the more optimal path on the fly as well. So it's ugly and again, this is an R&D project, so I agree. There are some places where things can get done better. That's what we're trying to do so much.
So one reason why HTTP is not that yet is that the over
Yeah.
the flow of connection or over caching in the caching environment, caching in the environment. You don't want to close it.
Yeah. So let me see if we got this right. There's a separate IPv6 address for every chunk, every encoding of every chunk. So you are actually now forced to close your TCP connection for every chunk, right? Well, I understand they're aggregated, but TCP, the way TCP works is you cannot maintain a single TCP connection if any of the 5-tuple changes. Right.
But if we did RG project, right? So if you start using your caches that you like to work with as gateway, then another way to accomplish this, get around that problem, and there may be others, but it's essentially establish a layer 3 physical in the VPN connection to that cache, and then route these addresses over that.
No, I understand you can do that. I don't see how that fixes the TCP problem.
Remember I had this optional
Yeah.
The cache could
Yeah.
potentially resolve those things and debundle that L3 rope.
Yeah, I understand that part. As long as every chunk of video has a separate IP address.
No, I hear you, you're right.
TCP connection cannot survive the change in any of the elements of the 5-tuple.
Yes. But if you, and what I'm saying is, one way we see getting around that is to build a layer 3 connection to the cache, which then will bundle the HTTP request as a single request, right? But route it using that address
No, I get that part.
to the server. And then the server decomposes that.
Yeah, I
and
get that
resolves
part
it
too.
back to get to the packet you want, but it actually goes over as a constant HTTP connection, but on top of that layer 3. Yes, exactly.
Well, then why bother assigning a separate IP address to every chunk? Then don't bother to do that.
And that's another way to package it. But again, this is experimental, so we have gone with this route because there are other similar efforts that have been shown. Cisco demonstrated one, and Church Communications last week in Paris was talking about another way that they were talking about doing the same thing. So there's converging ideas here coming together.
Oh. We should move on. Yeah. Oh, okay. Okay. I think we have I think we have a potential breakout session here for continued discussion. So there is definitely interest and very good. Yeah, that's another alternative.
Right.
Yeah, thanks a lot. So Jung Hao, you're next. I put them up. They are on.
No, it's really interesting stuff. I'll have your stuff up in a second.
Or you wanted? Yeah. Yeah. Okay. Okay. That's fine.
There you go.
Slow start. Come on. This one is running out of battery. Take the other one. This one definitely works.
Okay. Oh, yeah, it works. Okay. Yeah. Hi, everyone. I'm Chung Na Hong from IETF, and today I present the document which is merged between IETF and Huawei about the name resolution service requirements in ICN. We have been working for some time to merge this document. Before that, we had our own document for IETF and Huawei, and we both presented before in ICNRG. And then we had a very similarities in two documents, so we tried to merge it. And we also I have also discussed the stuff, this merges draft the last meeting in Seoul, and finally we just submitted the merged document for this meeting. So I'm just go quick review of the document. This is the history of the documents that I just explained, and the purpose of this document is we try to achieve a consensus that name resolution service is the most essential service which shall be provided by the ICN architecture. We are not, in this document, we are not talking about any kind of name resolution approaches or any design mechanisms. Regardless of these, we are trying to say in this document that NRS is the essential service which has to be provided by ICN architecture. So for that, in this document, we give the definition of the name resolution service in ICN. Also, we discuss the motivation for that. And then naturally, we discuss the requirements, things that we have to consider when we design the NRS in ICN. Yeah, next please. And this is the table of contents that we made. And just I explained on section 3 motivation, we give the definition of NRS and the motivation about the handling the heterogeneous names and dynamism in ICN. And then we discuss the requirements for NRS. And then we discuss some use cases of the NRS. Next, please. So in ICN challenge RFC, name resolution is the first step of the ICN routing. So the ICN routing may comprise these 3 steps. The first step is the name resolution, which translates the name to the locator, and the second step is the discovery, which routes the requester to the data object, either by name or a locator, which was resolved from the first step. And the third step is the delivery, which routes the data object back to the requester. So in RFC 7927, they discuss about the ICN routing. So they categorize the ICN routing according to the lookup by name or route by name or hybrid routing schemes, depending on how these steps are combined. But in this document, since we are talking about the name resolution, so we categorize this name resolution in 3 approaches in the next slides. But before that, we give the definition that we define the name resolution service as a service which shall be provided by ICN infrastructure to help a requester to reach a specific piece of content, service, or host using a persistent name. And these are 3 approaches on name resolution that we categorize. One is the standalone name resolution approach, and second is name-based routing approach, and third is hybrid approach. And standalone is the name resolution step in routing is separate from the discovery step, so which is use the DONA pursuit or say mobility first project. And the second name-based routing approach is the 2 steps are integrated. Actually, in the challenge document, they said the first name resolution is outdated, but we consider the tools are integrated, so we see this as a name-based routing approach for name resolution. And the hybrid is the name-based routing and can start first, or then the standalone name resolution approach can start. The both way works, different cases. And these are comparisons of the two major approaches between the standalone name resolution approaches and name-based routing approaches. According to, we compare these approaches according to the update overhead and resolution capability and node failure impact and maintain the databases. Well, since we are not emphasize which approach is better than the other, so I'm not go over all the details of the table, but we are just showing this comparison because all the approaches has a constant pros and cons. So regardless of the approaches, the NRS is the essential service which has to be provided by the ICN architecture. Next, please. So the comparison of the two name resolution approaches was just provided to motivate the requirements for the NRS. So when you all the different approaches has a pros and cons. So what we want to say in this through this document is when you design the NRS, you have to take care of these things. Yeah, please. So these are two motivations for name resolution service that we are talking in this document. The one is the handling the heterogeneous names in IC, and the other is handling dynamism in ICN. And the heterogeneous name includes the hierarchical name and flat name and human readable name and non-readable name. So all the different kinds of names can be handled through the name resolution service. And dynamism includes the mobility and multi-toming and migration and replication of the named data object. So these are also can be easily handled through the NRS. Again, I'm not saying that the NRS is the only way to handle these heterogeneous name or handling the dynamism, but through this document, what we are trying to say is through the NRS, these all the features of the ICN can be efficiently supported. That's what we are trying to say. Yes, next please. And these are requirements for the name resolution service that you have to consider when you design. So we categorize them into three aspects. One is operability, and second is manageability, and the third is security. So we just categorize into three. And today I'm not go over the details of it because we have done it before. So yeah, next please. And now I'll talk about the use cases of the NRS in the literature. So about the 4 cases, the first is in flat name routing support, and second is publisher mobility support, and third is scalable routing support, and first is the manifest support for nameless object in CCNS. Next, please. So, flat name routing is not easy with because the flat name cannot be aggregated, which can cause more the scalability problem in the routing system. So in literature, to address this problem, a flat name is resolved to some information which is routable through name resolution service. So as an example, in Pursuit project, the names are flat and the rendezvous functions are defined for name resolution service, and which is implemented by a set of rendezvous nodes, and the NRS is performed by the rendezvous network. And another project, Mobility First, they use a global unique ID as a name, and this is a flat and self-certifying ID, and they have the global name resolution service, which resolve the GUID to network addresses. Next, please. And the second use case is the publisher mobility support. So in ICM, there's two types of mobility. One is consumer mobility, and second is publisher mobility. The first one, consumer mobility support, is to how to return the requested data to a moving consumer, which can be supported naturally in ICM, because a moving consumer can always express interest after moving. But the published mobility support means how to forward interest toward the data created by moving publisher. This is more difficult to support since the routing table needs to be updated according to the publisher movement. So, next please. These are some solutions for mobility, publisher mobility support in literature. In NDN, they designed the rendezvous mechanism for interest to meet the data generated by the moving publisher. And the second one is a draft on forwarding label in CCN. They proposed this based on separation of the ID and locator names, and they defined the mobility service controller, which controls the forwarding label cache table, and this cache table caches the mapping between the name to locator. And the third project is the mobility first. In there, both consumer and publishing mobilities can be handled by the GNRS, which resolve the GID to network addresses. And third use case is a scalable routing support. And in the DFG of the ICN network, there is a routing scalability issue. So in NDM project, they designed the embedded in-cap system. In their data whose names prefix do not exist in DFG forwarding table. That data can be retrieved by NDNS, which is the DNS for NDN, which are designed for NDN routing. And this NDNS maintains and lookups the mapping information from a name to its globally routable prefixes. And the last use case is the nameless object support. In CCNX, they introduced the nameless object, which is the content object without the name, and this can be retrieved by a interest with the name and content object hash restriction. And here the name is used for routing, and the content object hash is used to identify the content. And in order to publish this nameless object content, one would first create a signed manifest with an authoritative name in it. So this manifest would need to enumerate the possible content, distribution names, and the nameless objects, contents of object hashes. So we need a specified method for manifest the lookup and this can be considered as a name resolution service. Yeah, this is all that I have for this presentation. And again, I would like to say that in this document, we are not trying to express or emphasize any approach of name resolution or any mechanism has to be used. We are not trying to say that. What we are trying to say is name resolution service is something that we need, has to be provided by the ICN architecture. So if we get, so I'm trying to get a consensus on that. If we get the consensus on that, then we can move that to work on the requirement when we have to consider designing of the name resolution service. So may I ask for the consensus on the NRS, just NRS in ICN first? Yeah.
So having watched the history of this, there are clearly some functions that are needed in any ICN to allow it to scale and deal with mobility and things like that, particularly if the names have no topological significance whatsoever, and you can't make things work. I think that maybe the problem that's slowing this down is the word service. In some sense, any ICN system needs name resolution, right? And name resolution can be embedded in the routing. It could be abstracted out as a separate function that the clients do. It could be abstracted out as a separate function that the routers do. I'm just curious if the room feels like, we can agree that these functions are needed, but when you take that extra step and say those functions are described as a service, that may be kind of already setting you on a certain path that we may or may not want to go down. What do people think of that?
I think I agree with Dave, but maybe I stated in a different way. I do not believe the service is the right term, but also because I think it's way too early to understand what the requirements are. Definitely some kind of mapping will be needed, but so far our experience have said that you can get that mapping information by all different means. Like for now, we have this so-called NDN fit application where you carry your iPhone, you report your health data. That also, to be able to fetch the data from your phone, it requires mobility support. But this mapping service actually is provided by the phone itself. When it try to contact we call the DSU, data storage unit, it will tell the storage unit to say, I'm here, fetch the data from me, so that the storage service will fetch from where the phone is located. So that doesn't really require a separate so-called mapping service. There are also other examples like this. I think I do not feel that I know the requirement for a mapping service at this time.
Well, I'm not sure if I understood quite well on your comments, but if I say on your comments that well, we are not only say the mapping between the name to locator. We would consider all kinds of name resolutions. So.
But like I said, there are different means to find the answer.
Right, but they can be, well, yeah, I'm not saying that one solution has to be provided.
But like this one, the example I mentioned, is actually built into the application itself. It's not separated.
Well, even in the application, well, that's a name resolution, right? No? Okay.
There can be, I would agree, there can be other places where you need a lookup. Yeah, maybe. But what I said is that I do not believe I can give a requirement at this time to say this is the requirement for lookup service. So far, we don't have a specific understanding, I believe, to say this is the requirement.
Yeah, as far as the requirements go, I agree with this requirement because in the last IETF we also had a draft which we call as the need for network identifiers in ICN. So fundamentally, there are a lot of issues. One is the edge computing. Then you want to do if you want to avoid things like any casting in the network, and you want to actually pinpoint this particular cache server that's where my content is. So even things like mobility, what we do with forwarding labels. So all the routing scalability, there are a lot of these questions that can be addressed with some kind of an interaction, and particularly if you're actually providing that kind of a network service in the network itself. Basically, having name resolution service as a network service within the network, so that you can do more efficient routing. So in that sense, I find it very useful, this particular piece of work.
So there's clearly some good material in this document. And my sense, I have my chair hat off here. This is just like sort of personal thinking about the technical aspects, is that we're sort of crashing on two words. And one word is requirements, and we just had a discussion about what, do we actually understand what the requirements are? And then the other one is service, because service is a highly overloaded term that usually most people interpret as ask a question, get an answer. And some of these approaches that, Lisha mentioned a few others, don't present themselves in the form of ask a question, get an answer. They sort of like might do a look aside, or they might route a packet to a particular place that has more information, and that can then route it on, and then when you get the answer back, there's some state that's sent back that makes subsequent requests more efficient. I mean, I think some of the stuff Ravi has done with these identifiers that wind up in subsequent packets to efficiently route sort of fall in that kind of a design paradigm. So I think there's something we can do here, but maybe it's not a straight line from here to there in terms of adopting a requirements document. So maybe we should have more discussion of this on the list, or maybe people can comment on particulars of the material in the document in terms of technically, is this the sort of thing we want to make sure gets captured? I don't know. I don't want to sound negative here. It's just, it doesn't seem like there's a straightforward path to say, hey, now, I think as Luca mentioned, now we have a set of requirements. Now let's go build a system that satisfies those requirements. Because we don't actually know whether the system we build actually needs to satisfy those requirements. Right? I don't know. Maybe I'm just blathering. I'll give up and stop now.
Well, then, if the term, like the system terminology is make confused or is not make sense, then what about if I change it service to the system which support the name resolution? Because I think there is a consensus or that we need the name resolution function as a function. So to make the function available, we need a system to support the function. So instead of saying name resolution service, what about name resolution service which support the name resolution function in ICN? Is that better or doesn't? Well, what about to use the system word instead of service? So make it the name resolution service to the name resolution system, because I think we can agree that we need the name resolution as a function. So we need a system to support that function.
Yeah, so I'm not sure. So, Chair had honor of. So the problem is that some people have is that there are standard bodies, which we are not, but there are standard bodies that use the term requirements for something very specific. So that's basically a document that creates normative requirements that need to be considered by later like designs and more specific specifications. And you want to be able to trace back your system design to those requirements. And so now if we are saying, oh, we are sponsoring a document on NRS requirements, this creates some allergic reaction. And so what I think would be really, really useful, so not saying that this is not useful, but what would be really, really useful is to document, experiments to show this is how name resolution can work, and this is our experience and our experiments. And so that should be, I think, the main purpose of this book. So we're not going to lay out the foundation of future standards right now. I don't think we should be doing that.
Actually, we already started to design and develop the APIs for the NRS using the CCS devices. So, well.
Okay, I don't quite know what we should do with this, but I have. It seems like everybody agrees that something is needed in this area. That I think everybody agrees. If that's a function, a system, a service, or something else, we have trouble agreeing on. Maybe we can take on for all of us, and especially for the chairs, to try to figure out, to formulate something that could be a work item in this area, how we should describe that so we don't get allergic reactions or have people thinking this is not something we should do. So would it be okay with you that we once again take this to the list, everybody can contribute on the list or direct it to the chairs, and we make a real effort to try to come up with some formulation, naming or whatever, so we can formalize this by the next meeting. Is that agreeable among the chairs as well? Or do you want to see something else?
I have a point I could interject. So going back to this slide, so whoever brought this up again, this is good. Like, what's the objective of the document? Do you want to, so the end goal here was about the requirements. if it's not the requirements, is it that you want to start defining APIs that you're hoping that these different flavors of NRS
The main,
conform to? So have we listed all the objectives here? So to what end do you want to capture all of this? How do you want to impact the community moving forward?
well, the main goal of this document is to present the requirements which has to be considered when you design the NRS. That's what you said, Lucas said, I think.
But once you have the
before-
requirements, which may still be evolving, I thought the conversation was also that, we have some of the requirements, we maybe don't know all of them, and then from a methodology standpoint, how would you use those requirements? And so one way you might use them would be about the APIs you're designing. One might be to, for people who want to build separate components that are NRSs or NRFs, whatever you want to call them, functions or services. So from a system building standpoint and from the standpoint of the community coming together to reuse this work, what's the component that emerges that is reusable from this? Is it APIs? Is it, anyway, so I'm just trying to figure out whether you've captured all the purposes of the stuff. I think the APIs is an alternate route.
Yeah, well, I tried to get the consensus of the consensus on the NRS service as a service first, and then when everybody in ICNRG agree that we need the NRS in ICN, then we can describe the requirements, things that has to be considered when you design the NRS in the actual system. So I tried to follow the step by step. So
constructive proposal, how about, so we also stop this one, so we can maybe sit together with you later this week and discuss a bit what could be next steps for, and get a better, plan for bringing this again. And then, so if you have time, maybe we could sit together with three of us.
yeah, sure.
So something just occurred to me, because there's a conditional statement that may be missing here. So, and you said it yourself, which is, if you needed an NRS, these might be really important things to consider if you were designing such an NRS. But the document also makes the presumption right here at the front that it's the most essential service in an ICN architecture, which then it's sort of like you're doing two things at the same time. One is you're making the assertion that you don't have a workable ICN without an NRS. And then we're sort of saying, and this NRS has the following requirements. Maybe we can think about being a little softer on the first part and saying, hey, some of these ICN architectures want to abstract out name resolution as a separable thing. And then come from the point of view, if you wanted to do that, these are the things you really have to think about. Right? And then people who say, well, I don't need such a name resolution service. My application can do it locally on the LAN, or I don't need it because my mobility protocol is like brilliantly designed. You can say to them, well, yeah, well, then you don't need this NRS thing. But because there's a lot of good material in here, we don't want to lose it. So maybe that's some way. So I think we need to soften the requirements word and maybe sort of say, we're working on various ICN architectures. Some of them may have or want to exploit a separable name resolution system. And if you want to do that, these are things you really have to think about. Because if you don't think about the security of the mappings, if you don't think about the update rate, if you don't think about this and that, you're going to wind up with something that doesn't work very well. Does that resonate at all with people? All right. So maybe we could capture that in the notes and use that as a sort of starting point to go to the next step.
If we capture that in the notes here, and then we could actually bring this up at the full meeting later in the week, and maybe we can agree then. Okay. Thank you very much.
Thank you.
Okay. My slides. So I'm going to introduce myself next. No. I'm
Are you response to?
Hello? Yes, now it's on. Okay, great. The first thing I should say is that this work is mainly done by Anders, and he should have the credit for. I have been mainly a discussion partner on this. And then this is more a discussion starter in this topic. It's not really a proposal on what to do and how to do it. It's more a question, what do we need in ICN when it comes to loss detection, retransmission, and congestion control? So, and it's basically taking the existing CCNX document as the basis. So Luca had some things you're doing in your version of CCN that's not reflected in this and so on. So, but I think we can have a discussion around this. Okay, this is just a basic introduction to the problem, showing in this, I think, fairly well-known paper that the green dots is the delay at one router, and the red one at the closer router, and shows that they used this method to detect where in a large network the congested link is. And then the blue thing down there shows the packet loss on that link. And this is really just to show that in today's network for sustainable times, you do have packet loss over 1% in the network. Okay, next slide. And then in CCN, we have a number of alternatives how we can deal with retransmission things. We can have these 64 kilobyte chunks that then are fragmented in some link layer in 1500 byte things where we don't have any retransmission underlying. So if one of these fragments is lost, we need to retransmit the full chunk. Another alternative would, of course, be to make each CCN chunk 1500 bytes, but that I don't think anybody wants to do for overhead reasons. So next. And just running this through MATLAB, you see that under these conditions, already when you get to 1%, a lot of packets needs to be retransmitted. So the color thing down there is the packets or fragments that needs to be retransmitted once, twice, 3, and so on. And the blue line that goes up is the total overhead for retransmission, the accumulated of all. So you see that already at 1%, you can't really sustain some useful CCN traffic by retransmitting at the CCN level. So something needs to be done if you want to be able to run over this type of links. Comparing with TCP/IP, you can see that in TCP/IP we have the IP layer that's best effort. And then on top of that, you can either have TCP to deal with this retransmission thing, or you can have a simpler UDP thing. And you have the APIs to this. Also, CCN Indian packets could be lost, especially if you mix too much IP traffic over the same Ethernet infrastructure, it's not reasonable to assume that we're not going to lose fragments that belongs to the CCN traffic. So we need some kind of mechanism to deal with this, and of course we could have link layers that deal with this. That's one option. But basic the question we ask here is, do we need to have some API that deals with these things of loss, retransmission, and congestion control in ICN? Okay.
Can I ask one quick clarification
sure.
question here? In the IP example, you also have this thing that you're measuring end to end, and the losses are hop by hop. So the loss measurements you're seeing in that slide were actually potentially over multiple hops, not over a single hop?
No, that was a single hop.
Right, so there's one hop, and then the endpoints are on that hop. In CCN or NDN, I assume you're talking about some kind of hop by hop mechanism.
Yes.
That is not some end-to-end thing, right?
Yes.
Okay.
Okay, next. So if we want to do something on this, what can we do? We can do some like a TCP-like approach where something underneath is hiding all this from CCN layer. For example, running the CCN on top of TCP. Or we can also do UDP where we just let the application deal with it. So basically we can have two APIs, one that only do interest in data messages and let something else take care of it, or the application take care of it. What we potentially could include here is that expose some information from the underlying layer up to the application, have a more complex API than a very simple one. Hold on. When it comes to underlying ways to deal with it, as I said, we can run it over TCP per hop. That there is this wireless loss detection and recovery that Luca and others have been working on that can deal with this. And then, of course, cellular networks has their way of doing it. Okay. So basically here, what I think is the aim with this presentation is to start a discussion relating to some figure that, like this one, is what APIs do we want to have for ICN or CCN when it comes to providing loss retransmission and congestion control. There are numerous places we could place it. I think this can sort of be an introduction to the terminology discussion also, that should we have, if you have this API 1 that just provide an unreliable get thing, then potentially you could have this reliable link layer underneath CCN, so you don't have to worry about these things. Or you could put something that provides this functionality on top of CCN and then get a reliable get thing at this API 2. And then you can do even higher APIs like the Flick, for example, where you do content manifest chunking and everything. So,
Putty?
Yep.
I think this misses some interesting combinations in the sense that you don't need to package loss detection, loss recovery, and congestion control together at the same part of the system. So you conceivably could do just loss detection in layer 2, and then hop-by-hop retransmission at layer at the bottom of layer 3. You could do loss detection at the bottom of layer 3, but end-to-end retransmission. So
That's not the intention to say that you have to do it.
well, it just puts, it basically says your alternative is to put L plus R plus CC down here, or L plus R plus CC up there. And I think that just gives the wrong impression, because they're,
Yeah, I agree that is definitely giving the wrong impression. But what it tries to say is that this type of functionality could be provided at these places, and not maybe all of it at the same.
I think if you're looking for input here, I could offer some, like our own experience as input to your consideration. I agree with Dave that it's not really bundled. Not only that, the so-called reliability is not necessarily either 0 or 100%.
No, and I'm not saying this is the way we should look at it. I'm saying that it would be very helpful if we could agree on a picture similar to this one, and we could map where we want to put different things.
yeah, the only reason I'm pushing on this one a lot is that in previous architectures, it actually was very difficult to disentangle loss detection from retransmission recovery because of the way things worked. And we have an opportunity through our stateful forwarding model and some of the many other changes we had, I think for the first time, to really look at decoupling loss detection from recovery.
Right. And even for recovery, you can come out of very different stages. So I was saying that I want to share some experience. What we have learned is that for very heavy loss links, you'd rather fix the losses, unless it's a congestion, that's a separate issue. But if there's a noise loss and some other issues, you want to do, we say, best effort loss recovery. That is, it does not give you reliability, but try the best without interfering with the end recovery, and do some quick recovery, as long as it doesn't introduce noticeable delay. So
Yeah,
that's called the best
I
effort.
think, Luca, your wireless thing does that, right?
Yeah, that's
Yeah.
exactly the same thing.
And
Yeah.
Similar
that's
thing.
what
So
was-
we had a great intern that did that whole set of experience. I think it's just the year before that the paper in last year's ICN conference. That's when I saw that paper, I thought it was a really great paper, captured that emotion. So that function is currently, as we speak, I think it's being put into this NBN link layer protocol.
Yeah,
LLP, so that it's not anything even touch upon the CCN NBN layer at all. Then even for the higher layer, I think, again, I'm just providing you the input. Okay, I think that one would like to give the option.
I'm not trying to propose a solution or where we should do this or how we should do it or anything like that. I'm just saying that it would be really good that if we had a common model with common names, where we know what we mean when we talk about this, so people can relate to it. That's all this is proposing to say.
I'm just offering, I think it ought to be, or at least our experience said that it's beneficial to have some kind of best effort, the low-level recovery, so that it really brings tremendous benefit to the perceived performance at the application level, and with virtually no cost.
And the reason we make this presentation is that we think this has been discussed too little in the ICNRG, so any contributions relating to this is more than welcome.
Just one remark about in the paper that you cite last year. So there's LRCC, but we made it also decoupling notification, because In notification, this is where you get really decoupling because the detection can be local. The notification, especially when you in the mobile environment, the notification is really important because in some cases you don't want to recover because recovering locally would be just meaningless because you're moving. So probably you should add another N, like to do the notification. Notification in the end is going to be end-to-end, but when you have this end-to-end notification, you can have the other local repairs that can be optimized in the global optimization that you do in the end. But so I would add an N into
The notification also, yeah.
So why is I agree with look on the either the N and also R here. Is that recovery or is it reliable? I think it should be two separate. There's one's recovery, but doesn't necessarily mean it's full recovery. That's the full recovery becomes reliability. So further splitting could be helpful.
Yeah. No, this is absolutely not a proposal on how we should do this. It's just an illustration to the picture that we would like to see, that is one that is common and everybody agrees on, that we can have as the basis for our discussions. So forget this one and draw a completely new one, and I'll be most happy to discuss that. But I think it would be helpful to have a common model, and where people, when they have proposals that we want to do loss detection in the link layer, or we want to do loss detection above the CCN layer, or what you want to do, so we can discuss and people understand where you are in the stack with your proposal, where you propose this mechanism to be operative.
So I don't want to obsess too much about this slide, but one thing on the slide I really do disagree with is that this CCN L plus R plus CC has to be TCP friendly. I don't think it does.
I don't agree with that either. That's Anders Baby, and I disagree with him as well as you do.
See, the precondition here says, because layer 2 is carrying both CCN traffic and legacy TCP IP traffic, therefore this CCN L plus R plus CC needs to be TCP friendly. That's not necessarily true if the link layer scheduler provides fair separation of the traffic locally. You've turned a local problem into a global problem unnecessarily.
Yeah, we say, I don't know, what's said in this slide said somewhere, or did in some version, is that, of course, if you do resource separation at layer 2, you don't have the problem. So definitely that's a possibility, and that's well acknowledged. But I agree that that's an important thing to point out. Okay, let's continue. Yeah, I think we said most of this. Basically, you can do it above the CCN layer, you can do it in the CCN layer, or you can do it below, and as they pointed out, it doesn't mean that you have to do all of these in one place. You can do some parts of it in one layer and some parts in another layer, and it's really having an organized discussion about how to do that, where it's optimal to do one thing or the other thing, and how this potentially can contribute to make ICN a much more efficient way of transporting information than IP is today, where you have this by necessity of how it's designed entangled into each other, which, for example, in wireless networks give very big problems when every loss is thought of as congestion. And then just pointing out the final thing here, that when dealing with this type of mechanisms, IP, where you do it end-to-end, you can evolve and do things like quick without that affecting the routers in the network. But in ICN, when you want to evolve these mechanisms, change them, you also will need to evolve the nodes in the network by necessity if you're doing this hop by hop.
So I agree with this, but I would say it the other way around, which is that TCP and QUIC have to be developed independently of IP router technology because we can't touch the routers. I mean, I think the proposition here is that we can actually do very much better than a pure end-to-end technique can do because we're allowed to touch the routers. Whereas TCP and QUIC, you know, are effectively hampered. They're hamstrung by the fact that they can only run end-to-end.
Okay, if you want to put it that way, I'm happy with that. Okay. Continue. So, as I said, do we want to formalize the discussion around how to do this in ICN and come up with some reference picture, terminology, and so on? I think that would be quite useful. We think that would be quite useful. So this is really a pitch for doing some more organized work in this area. That's all I just want to say.
So reference, I don't know, but what would be, I think, interesting is to, you know, see more what people have been doing in their implementations. So, for example, I think the guys at Park earlier, you know, also thought about like different types of layered APIs, and to just a good, solid discussion about the different designs, the experiences. That would be really useful.
Yeah. Okay. Yeah. Okay. Any other comments, questions? Okay, I guess we'll break for coffee then.
Yep. Great.
Let's be back 5 past, should we say? That should be enough.
Yeah. Some stuff here. Come on, let's see here. Oh, no. Here we go. And then I got vision file and I just noticed that the slides that Cisco guy had sent in, that's Cisco confidential on them. Yeah. So he just gave me another set.
I saw the. No, it's okay. I wonder if we can salvage this NRS work. I don't know. Yeah.
All right, so I need to get Bastian's slides. He sent some. Yeah. It's not going to go away. Well, we were to have a discussion on the email list. I mean, we don't talk about things privately, about what, you know, how we might be able to progress this work productively.
I think also it would be good to get away from the requirements word if we could do with something like guidelines or something like that, that probably causes pure allergic reaction. How to say that? We have a better word.
So I think the document maybe I would like to see is about, describing experiences of working with resolution in ICN. Okay. Yeah. So documents of others could be very fine to describe these different applications.
But I think also just collecting a lot of experience without drawing any conclusions, I don't think is that meaningful to do. So I think it's done. So experience and guidelines with name resolution in ICN, something like that. Because I think the goal must be that come to some kind of conclusion on it. So,
Well, let's see how it turns out in the notes, and then if something we just, see how we might make some proposals about what we might do. I'll have to look at the draft again.
So a problem I think is when you start talking about the high-level requirements without maybe having security systems, because you know, you're just assuming that these are things that could be important to consider. These documents are normally not so well conceived in this movement. We studied different applications for ICN, for analysis and this is what we found. I think that should be yeah. Yeah, this is what we came to know by doing experiments yeah, or analytical thinking or simulations.
So one thing we got, I know,
Yes.
particularly when I got up there, was many people in passing some of what I was thinking.
Nicht good at that.
Yes, they're good at that. But there's a higher order bit. So it's the, if you're going to do something with the issues, it's a component. If there's algorithm has one report that says, you tell me when you can use this thing. I can tell you what it does. But how do I decide which way to work? I want to look at it. Because nothing gets me. Whatever, and recommendation before you even get to that. Your book, which is even that you're using kind of looking for the assignments,
Yeah, good point. Oh, yeah. Sure.
Probably a business. Why don't we, why don't we talk about terminology that's very run out of time? Really simple. How much knowledge is something? It's that fucking. So the lands of kings, I'm telling you the necessary. So, and it's got 9 terabytes on it, so I'm gonna take a lot. Well, this is why my parity bridge really sucks. Once things get big. It takes you longer to recover than the lifetime of risk, so. Check out the virus scan. Takes a minute. I think this will come back. So they have to call Comcast and have them send a reset the cable modem before it came back. The interesting thing is I have my son Howard and that's what you do. Which is really weird. Must be some configuration disagreement. A good chunk of Cambridge went out. Uploaded the new slide. And my 5 Google windows each have that, and Chrome windows. Melman. It's an IMAP mail file. regular IMAP, but it does IMAP right. Yes, it does IMAP. Yeah, you can get it to what you want. It just doesn't fall over in scenarios that Apple knows. What actually got me to it is it supports both S-line and OpenTCP reasonably. Apple knows it's all confused sometimes, and just even refuses to tell you whether something's been signed or not. That's what caused me to initially do. And the search is reasonably fast, and it's threading well. Yeah, this does threading. Nobody does threading perfectly. One of the nice things is, so here's a mail message from Bastian. You can click on correspondence, and it does a search of everything related to that. Now, that's the only message in that category. But, better one would be, so that's everything back and forth with Alex about workshops across multiple threads. And then that's a nice smart mailbox. So here's a smart mailbox. Every message that has a PDF attached. It's really good at written virtual mailboxes. And then it does tags using the IMAP tags. It's not cheap. Yeah, it's not cheap. Yeah, that's cheap.
Ladies and gentlemen, the sooner we get started, the sooner we get finished.
No. You put up the slides.
Oh, yeah, there's no slides. There aren't many of them, but.
That's a bad George. I'm not putting them up.
Where's that? Here it is. Link in the window. Oh, that's not. Oh, it didn't do what I wanted. Oh, that was because it opened the draft. Open link in the window. Blow it up. Plug it in. And off we go.
Yes.
You should announce our, our meetings in the morning so that other people who want to come,
Yeah,
want to come. Yeah. Goodbye. Love to the family. Stay well.
Take care. Good night.
I will see you. Prague, if not before. Okay.
Okay.
All right. Take it away. It's down.
Yes, so for people that don't know me, my name is Bastian, and I'll just present a brief overview of the new version of the terminology draft. So next slide, please. A recap on the initial version. This version was submitted before the Berlin meeting, and we basically started out by just extracting ICN-related terms from the current working items at the time. Then during the Seoul meeting, we had several face-to-face meetings where we decided that the initial goal of this draft would be to facilitate the harmonization activity, because at that time, well, the document was a bit all over the place. So we decided to have that as main initial goal of the document. Next slide, please. So changes since that initial version, based on the discussion and conclusions we had back there, rearranged the overall structure to start out with a more generic section to explain the ICN concept in general, followed by sections on the CCN and NDN related terms and definitions, and leave it open for further and other architectures later on. So the generic section currently describes the ICN concept at a higher level, and it touches upon the request protocol, packet and content names, data authenticity and encryption, segmentation, versioning, and more, and all on a higher level. The third section we expanded now with some additional categories, and this section basically describes the CCN and NDN related terms for name types, name usage, data-centric security related things, ICN nodes, and the stateful forwarding plane. And we added the fourth section on the semantics and usages, and that basically describes the common purpose or common use cases and interpretations of the terms described in section 3. So for next steps, within the current version of the draft, there are still some terms that have like no description, like open definitions. Those still need to be addressed. And we also have a couple of unaddressed comments on version 0.0. So for this week, we have several face-to-face meetings planned during breakfast tomorrow and Tuesday. So if people want to join, we want to discuss some of these definitions and unaddressed comments, and also decide on the next steps for the document. And yeah, basically that's it. I had just a backup slide for, yeah, so I just, throughout the document, there are some open definitions, and I just put some of them here. Maybe we can discuss them now or later on. That's, but this is just to give an indication of what kind of things are still open and still under discussion. So questions or remarks?
Well, just from the point of view of the chairs, this document would benefit from more input from people, particularly people who have not sort of gone down into the depths of one or the other of the particular architectures that we're trying to cover with the terminology, because one of the most important functions of this document is to understand the things that are agreed and the things that aren't agreed, and be able to describe that crisply, and maybe not actually resolve all those things, but at least, you know, if people can agree crisply on what's different and why, it may be reason to leave them different, and it may be the best step for resolving things. So I think the team that's been working on this has worked very, very hard to try and get the right level of clarity here, and they've done a good job, but there's a lot more work to do. So soliciting help.
Okay.
Wait, yeah.
Yeah, one comment was basically related to what Chandra had mentioned on the NRS, and what Dave was mentioning as saying that, okay, this could be one of the components that could be added. The NRS could be one of the components that could be added to an ICN network for efficiency purposes. So in that context, I mean, because we had that draft for basically defining what a network identifier is and stuff like that, or locator. Are those being covered in this terminology now, or?
Not yet. We welcome contributions.
So I mean, when are you meeting tomorrow? I'd definitely like to join. You said there's going to be a meeting on this.
Yeah, tomorrow morning. I have to check. I think we're just meeting down here and then find a place for breakfast probably.
Okay. So would you kind of give that information on the mailing list?
Yeah, I'll forward it to the mailing list.
Okay, thanks.
Thank you, Bastian. Somebody want to do wrap up? You're good.
What about any IT stuff? Okay. So is there anything else that people would like to discuss today? So we have a bit of time left. Is there any new work items, ideas? So we have another meeting on Thursday.
Please look at the agenda for Thursday and make sure we haven't missed anything. Right.
Okay. We talked about this having breakout groups. That always seems like a good idea in the morning when you're fresh, and but I haven't heard anybody proposing any concrete thing here, and nobody was active when Bastian put up some potential terminology discussions. But, one thing we could see if somebody has something to say about this ICN and things to things. At least I think we have the chairs here. You're having some session tomorrow where for some new things. Maybe you want to say a few words about that to announce, because it might be of interest for people in this group.
Yes, so no. So we will have another of these summary meetings tomorrow, where we will describe what we have done in the meantime. But that's not really the main objective. The main objective is to make breakouts, which we're apparently not doing here, and discuss subjects that might need work from the research group. So maybe one of the breakouts actually should go in the direction of ICN, I don't know. But the idea is to really collect information and get people together that don't normally go to the research group and contribute their views on what needs to be done to make the Internet of Things a reality. So please please choose a breakout that you're interested in, and make sure that your points of view are recorded. That's all I need to say. Yes, 1300, I think.
One of you finished the status.
Here, close it.
Okay, yeah, please consider attending that Think to Think RD meeting tomorrow at 1 p.m. And please be sure to be at the ICNRG meeting on Thursday morning at 9. And Bastian is sending around some information about getting together on the terminology draft. Thanks all for your presentations and discussions. I'll see you around. Meeting finished.
Thanks, everybody. See you Thursday or earlier if you're doing any of the other activities.